Hey, sixth graders, so welcome. I'm going to do a really short video today. The title's right there up top. It's called One-Step Inequalities Using Addition and Subtraction. Now, this is much like solving equations. The only difference is we have this little sign right here. Now, that sign does mean less than. So let's go through this. We're trying to figure out what Q stands for. Now, it says 3 plus Q is going to be less than 10. So we have to figure out what Q can be. Now, unlike solving equations, when we solve an equation, we're trying to find the actual number that the variable stands for. When you have stuff like this number, this variable can stand for many different numbers. So what I have my class do is I have them draw the wall, okay? And I have them bring the sign down, okay? Now, same thing as solving equations. Now we brought the sign down, we can forget about it. 3 plus Q is less than 10. How do you get rid of the 3? Because you still want to get the Q by itself. You get rid of the 3 by subtracting it because it's a positive 3. And that cancels out. You have to do the same thing to both sides. What is 10 minus 3? 7. So now you have Q is less than 7. Now, when you graph this on a number line, here's the only different part. Like, I want you to think in your head, was this difficult? Absolutely not, guys. Again, we've done equations for the past week and a half or so. Instead of having an equal sign, you just bring this less than sign down. Same thing as equations. Here's the only part that is different. I'm going to use one of these blue lines to help me out. You have to graph this on a number line. Remember, the number line keeps going both ways. Okay, so what I do first is I find my 0. And then I find this, the 7. Okay? Now, I am telling you, and you guys can see right here, that Q is less than 7, which means, look, the mouth is trying to eat the 7. So no matter what Q is, it's going to be smaller than 7. Do you guys agree? Okay? So Q has to be smaller than 7. Here's the only thing. You have to color in this dot right here. Now, I'm going to do a little side note. When it's greater or less than sign, you're going to leave an open dot on the number line. And when it's greater or equal to, you're going to color it in. Less than or equal to, you're going to color it in. It's like a scantron. I'm going to leave that dot open because can I put 7 right here? 7 is less than 7. No, I can't. That does not make sense. Remember, Q has to be anything in the entire world as long as it's smaller than 7. Okay? So a 7 will not work. But check it out. If it's a 6.999999, will that work? Absolutely. So what you do on your number line is you color the side that could be Q. So if I pick something over here that's bigger than 7, like a 10, is 10 less than 7? No. So that side doesn't work. So what I tell my students to do is look at the 0. Is 0 less than 7? So replace the Q with this 0. Is 0 less than 7? Yes. So you leave this open dot and you color that side of the number line. And that is the answer to this inequality. And that is how you graph it. Okay, here's another problem. H minus 4 is greater or equal to 12. So first things first, I want you to forget about this sign for a minute. Draw your wall like you're going to solve an equation. So again, forget about the sign, bring it down. Greater or equal to. Now just solve this. How do you get the H by itself? You have to add 4 to both sides because that says minus 4, same thing as negative 4. Add 4 over here to cancel that out, and I add 4 over here. And now you're going to get 16, and then you're going to bring this H down. Okay? So we understand that first part, just like solving an equation. Now I'm going to draw my number line like this. Okay? So what I always do is I put my 0, and it's your number line. You can do this however you'd like. And then I put this. It's a positive 16, so I know it's going to be over here. It doesn't matter where it goes. Positive 16. Now, this tells us, this right here, this tells us that H has to be greater than 16 or equal to 16. Do you agree? H has to be bigger. It's eating that side. So this is going to be bigger than 16, or it can be equal to 16, right? So this is why, just like a Scantron, could 16 be the answer? For instance, you don't have to write this part down. But if I put a 16 here, is 16 greater than 16? No. But is 16 equal to 16? Yes. So 16 could be the answer, so I'm going to bubble that in. Do you get that? Okay, I'm going to scratch that away. Now, what I tell my class to do, I already have my 0 on the number line, so put the 0 here and see if this works. Is 0 bigger than 16? Absolutely not. So that means we can't use anything on this side of the number line, but we could use anything in the world on this side of the number line. And I just want to elaborate for a second in case you are confused. Like, we can use anything over here, meaning I could use 20. Is 20 greater or equal to 16? Yes. I could use 100. So 100 would be way over here on the number line. Is 100 greater or equal to 16? Absolutely. So my inequality, the answer, let me scratch that out so you can get confused, is H is greater or equal to 16. Okay, 6th grade, I got 2 more examples and then we're done. So again, before you begin, imagine that's an equal sign like it's an equation. Draw your wall. How do you get the z by itself over here? You're going to add 7 to both sides. That goes away. Now, 6 plus 7 is 13. So your answer is going to be z is less than 13. Okay? Now, as you graph this on the number line, that should be the easy part. I understand that graphing it might be a little difficult. So find the 0 on the number line. That's a positive 13. Doesn't matter where you put it as long as you put it on the positive side. Now, z has to be less than 13. You're going to eat the z. So, like on a Scantron, could 13 be the answer? So I'm going to write this, you don't write it. If I put 13 here, does that make sense? Is 13 less than 13? No, it's not. So 13 can't be the answer, so we do not color it in. We leave the dot open. Now, like I said, what I do with my classes is I take this 0 and I put it right here. Is 0 less than 13? Would you rather eat the 13 over the 0? Yes. So that means you shade in that side. Okay? Now I'm going to skip straight to the last one so we can get this over with. Again, this is a tricky concept. If you're getting it, then you're doing awesome. So t plus 9 is greater or equal to 10. Draw the wall like you're solving the equation. Bring your symbol down. How do you get rid of the 9 away from the t? You subtract it. 10 minus 9 is 1. So t has to be greater or equal to 1. Right? So I'm going to draw my number line. I'm going to add my 0. That's a positive 1, so I'm going to put a 1 right here. Now, again, could 1 be right here? Is 1 greater than 1? No. But is 1 equal to 1? Yes. So that means I would bubble this in. And now I have to figure out which side of that 1 I'm going to color in. Okay, because remember, on these, unlike equations, there can be multiple answers, like an unlimited amount of answers for the variable. Okay, so now replace the 0. Is 0 greater than 1? It is not. So you could not use anything on this side of the 1, but you could use everything on this side of the number line. Okay, so go with this. I hope you took your notes, and if you need to, rewind it, watch the problems again, and you should do just fine.